Hi everyone, my name is Amitesh, and in this video we're going to master this problem over there, which is going to involve several fundamental concepts and limits. So we're going to learn how to figure out when to apply what and how to approach complex math problems using limits. And this is a problem, it's very similar in style to problems that I've taught in lectures in freshman calculus at Princeton University, or in problems that have appeared in exams when I've taught freshman calculus in Princeton University. So it's a very fundamental problem to master, and it's a really nice problem. I love it a lot because it uses a number of different concepts. So let's just dive right into it. The question is, find and characterize the discontinuities of f, which include basically when a point is not in the domain of f. And try to understand, whether they are holes, whether they are asymptotes, jump discontinuities, etc. So let's just figure out how we'd go about it. So step one in these kinds of questions, when you're trying to understand this, is to actually find the domain of f. Okay, so that's step one. So we want to find out what is the domain of f. So step one is find the domain of f. And I always emphasize that when you're trying to find the domain of a function, the thing you're trying to do is to figure out what is illegal and whether those things are happening in your expression. So you cannot take the square root of a negative number and you cannot divide by 0. Okay, so those are the things you should think about when you see a square root and a fraction and you're finding the domain. So here what we can do is we can ask what's the expression inside the square root, and actually this is going to help us a little bit in understanding the problem anyway. And actually the first step is to see that the expression inside the square root is always non-negative. And I want you to pause and think about why that is quickly, but I'm going to get into it. So it's non-negative because it's actually a perfect square. If you think about factoring a quadratic, it's going to be x minus 1 squared using the binomial theorem. I've done a video on that on my channel, check it out. Lots of cool ways of looking at it. But x minus 1 squared, and you're dividing by x squared plus x minus 2. So let's just factor that too, okay? Because we want to understand when that is 0. So potentially we need to understand how to factor it. That's going to be important. So factoring that, I just like to think of it as x squared plus 2x minus x minus 2. So you've got the 2 minus 1 is 1 and the 2 times minus 1 is minus 2. So you've got the two numbers that difference is going to be, or their sum is going to be 1 and their product is going to be negative 2. So then you can factor in that way. So we're going to now work out what this is. So this is just going to equal to the square root of x minus 1 squared divided by x times x plus 2 minus 1 times x plus 2, which is going to equal to the square root of x minus 1 squared divided by x minus 1 times x plus 2. Okay, so that's going to be the expression you're going to have. And already we see, that 1 and negative 2 are not going to be in the domain because you can't divide by 0. Okay, so that's number one. And number two is to understand the square root of the x minus 1 squared. Now I've done a video on this on my channel. The square root is not the inverse of a square. It's a mistake I've seen a lot, in college calculus, in high school math, everywhere. Square root of x minus 1 squared does not give x minus 1 back. So check that video out if you want to understand this deeply, and it'll really help. But here the square root of x minus 1 squared is the absolute value of x minus 1. You think about it, if x minus 1 is positive, then square root of the square gives a number back. But the square root of a number is always going to be the positive number that squares to be it. Okay, so it's a positive value or a non-negative value if the number is 0. And so if x minus 1 is negative, like for example, if you're taking negative 3 and squaring it, you're getting 9, and you take the square root, you get 3. Okay, so you have to take the absolute value of x minus 1 on the top. So we're going to get the absolute value, I'm just going to write it in black, the absolute value of x minus 1 divided by x minus 1 times x plus 2. And this is a perfectly nice way of writing the function. Okay, so what was the motivation for doing this was to just factor. When you see an expression like this, you're thinking of limits, it helps to just factor from the start. So we kind of factor everything out and we understood we got this. Okay, so that's number one. Now, what does it tell us about the domain? So let's just write that out. The domain is going to be all numbers except when the denominator is 0, because you're not taking the square root of a negative number. So the domain is going to equal to, so domain of f is going to equal to, I've done a video on interval notation if you want to master it, but you can write it in interval notation, negative infinity, negative 2, union negative 2, 1, union 1, infinity. Okay, so all this means is that I'm excluding negative 2 and 1. This is all numbers between negative infinity and negative 2, all numbers between negative 2 and 1, and all numbers from 1 to infinity. Okay, so watch to the end to see a really cool fact about this problem. We'll find out that, when you're trying to understand this, it's going to be something very critical with the absolute value that's going to come into it. Okay, so watch the end for that. And I've just highlighted the domain there, so we'll have to understand the limits at 1 and -2. Okay, so that's where the points are not in the domain. Outside of the points, the function is continuous, because it is a ratio of two continuous functions. Continuous are things that kind of change like in a continuous way. So intuitively, you can just understand that the ratio of two continuous functions is continuous, provided it's well defined. This is a mathematical theorem. So now we've kind of got that expression. Let's kind of understand what the limits are. Okay, so there are two more steps to this problem, and I want you to try to think about how you're going to do this and what's going to happen. Okay, so we're going to do the first one, which I like to do, which is going to be the limit as x approaches 1. Just let's do 1 first. It doesn't matter what order you do it in, but we'll do the limit as x approaches 1 of this expression. So I'm just going to put a little box here. So limit x goes to 1 of this expression, what's it going to be? Well, it's going to be, so let's write it out, limit x goes to 1 of this expression, which is going to be absolute value x minus 1 divided by x minus 1 times x plus 2. Now, first thing is to plug in with the limit, and as we know, we plug in, we're going to get a 0 on the bottom, which means we have to do something more. You know, whenever you do that in a limit. So if you plug in x is 1, you're getting 0 on the bottom and a 0 on the top. Okay, so you're going to get 0 on the top, 0 on the bottom. So it's a 0 over 0 indeterminate form, which means that I've done videos on this, check it out based on lectures. In the style and content I've given at Princeton, I've talked about like 0 over 0 limits on my channel, and you can sort of figure out, when you have a 0 over 0 limit, the key thing is there is a culprit on the top and bottom that you have to cancel off. Okay, so here you basically want to figure out what to cancel from the top and bottom so I can plug in, and the culprit is the x minus 1, that much we can see. The x plus 2 is going to be 3 as x goes to 1, so it doesn't matter, that part doesn't matter. But how do you cancel off with an absolute value? And here's the thing I always remind you with absolute values. I've done plenty of videos on them on my channel. Check them out to really master them because they come up everywhere in calculus. But the thing to remember, the core principle is that when the number is positive, the absolute value is the number back. When it's negative, the absolute value is negative of the number. So it depends on what you're taking the absolute value of. So we have to consider cases separately. Typically with the absolute value, there's no way around that. You have to look at when it's positive, when it's negative, and understand that. Okay, so number one is the absolute value. Let's look at the right hand and left hand limits. Okay, so the right hand limit, and this is always something you have to do when you have an absolute value, generally speaking, because it's going to depend on which direction you approach. X approaches 1 from the right is x is greater than 1, so absolute value of x minus 1 is x minus 1 back, because x minus 1 will be positive when x is greater than 1. So we're just going to get, this is going to equal to, so I'm just going to write this out, x minus 1 times x plus 2. It's going to equal to limit x goes to 1 from the right of x minus 1 divided by x minus 1 times x plus 2. So that's all well and good. We can cancel off the x minus 1s from top and bottom. And if we cancel off the x minus 1s from top and bottom, we're just going to get, because x is not 1. X is approaching 1, but it's not 1. Limits only care what happens near the point, not at the point. So here we can just say this is limit x goes to 1 from the right hand side of 1 over x plus 2. So cancelling off something non-zero on top and bottom because it's a limit, and this is just going to equal to 1/3. Okay, so I'll just write this out. This is equal to 1/3. That is going to be limit number 1. Okay, now that's limit number 1. The next thing you have to do is you have to figure out the left hand limit, because the absolute value is going to change because you're going to take the absolute value of a negative number. So the right hand limit I have calculated. Now actually I'm just going to erase this part and actually show you that the left hand limit is very similar in nature with one important point. So the important point is that when you take a left hand limit, x is going to be less than 1, so x minus 1 is negative. And the absolute value of a negative number is going to be negative of that number because it always has to become a positive number. So here we're going to say this is limit x goes to 1 from the left of negative of x minus 1. Okay, so we're going to get negative of x minus 1 on the top divided by x minus 1 times x plus 2. And here what you can do is you can just cancel a x minus 1 from the top and bottom. Again, it's 0 over 0 limit, but x is approaching 1, not exactly 1. And now you can work out that this is going to equal to negative of the limit. The negative sign can come out because it's a constant of 1 over x plus 2, which is going to be negative 1/3. So we see that the limit is going to flip sign if depending on which direction you approach. So therefore, what's going to happen is the left-hand limit and the right-hand limit are different. So it is not, limit doesn't exist as x approaches 1. Okay, so that's what we're going to write out. So I'm just going to erase this off. So we can sort of erase this off. The limit does not exist, but what happens is that even though the limit does not exist, you can sort of say what the left-hand and right-hand limits are. So this is what we call a jump discontinuity. Okay, so a jump discontinuity is when the left-hand limit as x approaches 1 of this expression of f of x is going to equal to negative 1/3. Okay, so I'll write this out here. It's negative 1/3, which is not equal to the limit as x approaches 1 from the right of f of x, which we know is equal to positive 1/3. So this is a jump discontinuity. As x approaches from the left, you can sort of visualize it on a graph, which I find often very enlightening. I'm not going to graph the function in this video, but I can sort of just show you what typically a jump discontinuity looks like. So as x goes to 1, negative 1/3 is here, positive 1/3 is here, and your graph is going to sort of go something like that, right? So you're going to draw two little holes there, and you're going to sort of say it's going to go here, then it's going to jump and go like that. Okay, so this is a discontinuity of the graph, but 1 isn't even in the domain of the function. Okay, so that's the characterization of that point. Now let's do the other case, which is when x approaches negative 2, and this is a very fundamental example of a dividing by 0 limit where the numerator is non-zero. I've done a video on that, understanding that deeply. I encourage you to check that out. This is going to be one level higher than that video, but if you haven't seen that video, I always aim to explain everything accessibly in every video, so you can try to understand the concept here as well. Okay, so what we're going to do is we're going to take the limit as x goes to negative 2 of this expression. So it's going to be limit as x approaches negative 2 of absolute value x minus 1 divided by x minus 1 times x plus 2. Okay, so that's going to be the limit we're looking at. And what we see is that we plug in. Okay, always plug in to diagnose. Okay, it's like you're a doctor. You're trying to diagnose what the problem is. So you need to plug in to do that. And the first thing is that, as x approaches minus 2, the top is going to be what? Well, minus 2 minus 1 is minus 3. So it's going to approach the absolute value of minus 3, which is going to be just plus 3. Okay, absolute value of a number is its distance to 0. Okay, that's why it's defined. Minus 3 is 3 units from 0 on the left in the number line. And similarly, x minus 1 times x plus 2, well, this is going to go to 0 because we know that the denominator is 0 when x is minus 2. But this expression, this x minus 1, what's it going to go to? Okay, so I'm going to be very precise here for a reason that will become clear. Is negative 2, negative 1 is negative 3. So it's going to go to negative 3 times 0. Okay, so it is a non-zero number over a 0 number limit. And this is very different in nature from 0 over 0. It is not an indeterminate form. Okay, so if you think it is, I just want to emphasize it's not, because the value can be determined. Okay, when you're dividing a non-zero number by 0, that is always going to be plus or minus infinity. And what's going to matter is what the sign of that non-zero number is. Okay, and what direction you approach the point. 0 over 0 limits are called indeterminate forms because you actually have to do some cancellation and simplification, and the value could be anything. Like the previous example, we saw 1/3, negative 1/3, could be any number, okay? But here, what we want to do is, we want to think what happens when x approaches negative 2 from either side, because if you think about the 1 over x, which I've done a video on, limit x goes to 0 of 1 over x. As x is positive, it goes to plus infinity. As x is negative, it goes to negative infinity. So what you want to do is you want to split into a right hand and left hand limit and understand what's happening. So here it's the same idea. Limit x goes to negative 2 from the right hand side of this expression. Absolute value x minus 1 by x minus 1 times x plus 2. Well, what we're going to do is we're going to note that as x approaches negative 2 from the right, x plus 2 is going to be a positive number. Okay, so I'm going to write that out in a little kind of note here. X plus 2 is going to be positive because x is approaching negative 2 from the right of the number line. Okay, so you can draw that. And because of that, this expression is going to be 3 on the top, right? Negative 3 on the bottom, and a positive really small number. Okay, so it's going to, the 3 and the negative 3 are going to become negative 1, right? 3 and the negative 3 are going to become negative 1. And on the other hand, so that's going to be a negative 1, but we're dividing by a very small positive number, so it's going to become negative infinity. Okay, so that's the explanation there. So it's going to be, we can sort of write this limit is going to equal to, so I'll write absolute value x minus 1 divided by x minus 1 times x plus 2 is going to go to, roughly it's going to go negative 1 over 0 plus. Okay, so I'll sort of write this out. I've cancelled the negative 3 and 3 from top and bottom, so I'm getting a negative 1 on the top, and sometimes people like to write it like this, 0 plus, just to say you're dividing by 0 but a positive number that is close to 0. Okay, that matters because the sign is now going to be negative infinity. Okay, so that's the left hand limit or the right hand limit as x approaches negative 2. For the left hand limit, it's going to be very similar. So I'm going to now erase this all off, or at least just change this around just to kind of show you. So for the left hand limit, x plus 2 is going to be negative. If x approaches negative 2 on the left on the number line, x is less than negative 2, x plus 2 is negative. So here we're going to get a negative sign. So when you get a negative sign here, we're going to get that x plus 2 is going to be a negative number. And now what you can do is you can see it's the same deal, okay? The absolute value x minus 1 and x minus 1 were non-zero. They were 3 over negative 3, which is a negative 1. So you get a negative 1, but over a small number that is close to 0 but negative, okay? So it's going to be a 0 minus, and here we're going to get a plus infinity. Because you're dividing negative 1 by a small negative number, the negative signs cancel off, you get plus infinity. So because the left-hand limit and right-hand limit are different, the limit does not exist, but it is a vertical asymptote because the function is going to negative infinity on the right-hand side and positive infinity on the left-hand side. So we can sort of write that out, you know, if we sort of try to visualize, really zoom into that graph, you know, we can sort of zoom into that graph and we've got the point where you have x is negative 2. Then as x approaches negative 2 from the right, it's going to go to negative infinity. So we sort of draw this vertical line. This is going to be our vertical asymptote. We sort of say vertical asymptote, asymptote at x equals to negative 2. So you can sort of imagine your graph. It's going to kind of go on the right hand side, it's going to go on the left hand side, it's going to go to positive infinity. So on the right hand side, it's going to go to negative infinity in our calculation. And so that's going to be our function, our graph near that point. But the question only asks us what is a discontinuity and to characterize it. So we've done that for both of these. And I hope this is really helpful in terms of understanding, you know, when to diagnose, when to split into left hand and right hand limits. Remember, split into left hand and right hand limits when you have absolute values and 0 over zeros, or when you're dividing by 0, you know, then the sign may matter. So think about that. And that's how you know, that's how I knew to do that. And we've got a vertical asymptote, so we've understood non-zero over 0 limits, and we've also understood 0 over 0 limits with the absolute value, which generally tend to be jump discontinuities. So thank you so much for watching. If you watched this video this far and you loved it and you benefited from it, please consider liking and subscribing. It just takes a second. You know, making these videos takes time for me, but I love doing it to help people. But watching it is free. Liking and subscribing is even easier than watching. It takes a second. So go ahead and please click the like and subscribe button. Share with friends and family. You know, if you're benefiting from it, your friends may also benefit from it if you're doing the same class in university. And I really want to reach as many people as possible to change lives through math education. Elite math education, you know, straight to your room, without paying for it. And so by liking and subscribing, you really help me out in terms of achieving my goal. So thank you so much. I'm super excited to see you in the next video. I wish you all the best. Check out the content on my channel. We've got lots and lots of cool content. Check it out. Check out my YouTube channel. I'm aiming to upload math at all levels of math, all different kinds of math over time, okay, to create an infinite library. So if you subscribe, you'll be notified of that always. So wish you all the best. I'm really grateful that you watched so far, and I love making this video. I hope I was able to support you, and I will see you in the next video. Please take care.